Good afternoon, everybody. Today is the 3rd of July 2020, and I'm going to make a revision tutorial on thermochemistry, and the number is S9 thermochemistry. I may divide into two parts so that it won't be too long. I try to use about 20 minutes to deal with the basic things, and then for part 2 I'll do with the medium difficulty one. So let's go to the basic one. Okay. Thermochem is something to deal with the heat change when there is a chemical reaction. It's either heat energy given out or maybe other form of energy. Usually it's heat. If energy is given out, it is exothermic, and if you have absorption of energy, then it will be endothermic. And we have to measure heat, and we will recognize some special type of heat change which appear frequently in the examination. And also we'll look at some practical skills in calculation. Okay. First of all, to be simple, we look at number 1. When there's heat change, and then the reaction mixture, usually a solution, an aqueous solution, which mainly consists of water, will have a temperature rise delta T, and the mass of the solution, we treat it as the mass of water, and the solute there we think that is negligible. We don't count the solute. We just treat the whole solution to be water. Then it have a specific heat capacity of 4.18. Okay. And now for the energy given out, it will heat up a mass of water to a temperature rise of delta T. And if we want to have a higher delta T rise, then we must have higher amount of energy. Therefore, they are direct proportional. And if we want to heat a larger mass of water, then we need to have a higher amount of energy. So the energy should be proportional to m, and also proportional to delta T, the difference in temperature. And in this equation, the proportional constant is C. It's called the specific heat capacity of that substance. It is something to do with the nature of that substance. Okay, so it's actually physics, not chemistry, but we have to use this formula. If you don't understand too much about physics, then you just memorize E equal to mc delta T. Some books say theta, mc theta. Okay. Now for number 1, we want to calculate the heat, the amount of heat required to raise the temperature from 15 to 35. The difference is 20, and you have 100 gram of Fe2O3. Okay, then we just substitute the mass, 100 gram, and then we have the specific heat capacity. Let me underline for you. Specific heat capacity of FeO3 should be 0.634. So mc delta T, straightforward. Then you get the answer. So everybody understand this one? This is a basic one. E equal to mc delta T. Now we go to number 9. Okay, we just jump to number 9. And number 9, we look at this one. We have a reaction of lithium is a group 1 metal reacting with oxygen. So metal and non-metal, they react very vigorously and form lithium oxide. And according to the equation, the standard heat change, standard, this symbol means standard, is the 25 degrees Celsius room temperature and also 1 atmosphere pressure. This is called the standard condition. Okay, and the substance have the natural state which they appear under that condition. Alright, so what does it mean? This means that if 4 moles of lithium react with 1 mole of oxygen to give 2 moles of lithium oxide, then the heat evolved will be 1198 kilojoule. Okay, the negative sign means heat is given out, because for delta something in science, it is always the final state minus the initial state. So the final state must be smaller than the initial state, so that the final state, the smaller one, subtract minus the initial state with the higher one. Okay, and then it will be a smaller number minus a bigger number will be negative number. So when the reactant become the product, the energy, the enthalpy content or the energy content become less, so that you have a smaller energy at the end. Okay, so I don't deal with this too much because it's so basic. Now this is called thermochemical equation. Everything is proportional in direct proportion. It means 4 moles of lithium will give minus 1198 kilojoule. If you have 8 mole, then you have to multiply that by 2. Okay, so it appear in the equation is 4 mole and it is 1198. Okay, then we can do a direct proportional. We use the cross multiplication. Now we want to release 551 kilojoule. So according to the equation, 4 moles of lithium will have delta H minus 1198 kilojoule. And what about now we want to have x gram, x is the mass, over the molar mass of lithium metal. So the lithium metal have 6.9, so this is the mole, number of moles. So 4 direct proportional to minus 1198, and then x over 6.9 directly proportional to minus 551. Then we do the cross multiplication. This one just multiply to this one equal to the other way, the cross multiplication. Then you have 12.7. So in chemistry you always use cross multiplication. It can do all kinds of calculation. 係無敵㗎, is almighty. Okay, nearly almighty. Okay, so we do the basic one for number 9. In this one, we know what's the meaning of equation, the thermochemical equation. It always refers to the number of moles appear here. Remember, okay? Then you always use the direct proportion to do that. Now, then we jump to another one. I want to jump to number 12. Number 12 here. Number 12. Okay. Now you have barium with oxygen, and under the standard condition, okay, to form barium oxide. Barium is group 2, so BaO. Then you know that 1 Ba give 1 BaO, so it's 1 mole to 1 mole. You can write the equation, but you can save it. You don't have to write it down. You just understand that 1 mole of barium give 1 mole of barium oxide. Okay. Then you can do the calculation. Okay. So when doing so, you have 11100 joule. Okay. Then you have to calculate the number of moles of barium first, because we want to calculate the enthalpy change of formation, the standard enthalpy change of formation of barium oxide. By definition, is 1 mole of barium oxide, 1 mole, okay, formed from the elements in their standard state, okay, 1 mole of that substance formed from the elements, that's O2 and barium metal, under the standard condition, which they are in the standard state. O2 will be gas, Ba will be solid. Okay. Now we know the total heat given out by this amount, 2.75. So you have the total heat change divided by the number of moles. In doing so, you convert to 1 mole. Okay. You convert to 1 mole. Okay. The mass over the molar mass, 137.3. How does it come? The barium here. Okay. Because you're given barium, and then you over barium, the molar mass, then you have the number of moles of barium. Because 1 mole barium gives 1 mole of barium oxide. Therefore, this also 1 mole barium oxide when you divide it by the number of moles. Okay. So in this example, we learn about something to calculate. It is that we find the heat evolved and divide by the number of moles present there. Okay, it's very important in your practical, in your laboratory findings, in your experimental results calculation. You have to know the total heat change, mc delta T. Then you divide it by the number of moles. You have the mass of substance form or mass of reactant. You divide it by the molar mass and put it in the denominator. In doing so, you change it to 1 mole per mole. Okay, then you give the 555. Okay, so this is also a basic one. After the number 12, we go to number 14. Now it's propane. We go to organic chemical, propane, and it give that amount of heat to 3.56 grams of propane. Okay, then you have to convert it to mole. Therefore, we divide by C3H8. So 3 times carbon 12, 8 times hydrogen, which is 1. Then we get the number of moles of propane. Then we have total amount of heat divided by number of moles. So it is the same as number 12. You must know how to calculate the heat of combustion, the standard value of heat of combustion. You have to convert to be 1 mole of the substance completely burned in oxygen, okay, or excess oxygen. Must be completely burned, okay, must be 1 mole. So we always divide it again. We also always divide by the number of moles in the experiment. Okay, in the experiment you use some mass which is not 1 mole. You convert into 1 mole, and then in doing so you divide it into the denominator. So I hope you learn this one. Okay, the basic one. So I do another one. So let me do another one, similar one. Okay, we have 3 examples about this one. This is an experiment, KOH, an alkali, strong alkali, corrosive. It's called caustic potash. Caustic means corrosive. And you have hydrochloric acid, strong acid. Okay, 1 mole to 1 mole, they react. Okay, and we are going to let me see. You are given some volume, and you have KOH 0.03 mole, and then HCl 0.03 mole. So for neutralization, the definition is related to 1 mole of water form. Remember, the important form is that 1 mole of water form. So we calculate the number of moles of water first, because 1 mole KOH with 1 mole HCl give 1 mole water. Therefore, all of them are 0.3. Okay, first of all you find this one. Okay, then you mix the solution so the heat is given out, and the total volume will be 150 plus 50. Okay, so you have water 1 gram per cm cube, and the resultant solution, we assume that the heat capacity is the same as water. So we have 100 gram multiplied to mc. This is a C. Okay, it's a water, the heat specific heat capacity of water. And then you have the elevation of temperature. This time I used the Kelvin scale to remind you that actually Kelvin scale, the difference between 2 Kelvin scale is the same as the difference between 2 in Celsius scale. Okay, so K mc delta T. Okay, because it's increased by 3.9 degrees Celsius, then we have this amount of heat, and you use this heat and then you divide it by the number of moles of water, because the question asks you about enthalpy change of this reaction, which refer to this equation. In this equation you have 1 mole water here, so you have to divide it by 0.03. So to convert the delta H to 1 mole per mole. Okay, in that way the unit will be kJ per mole. You have per mole here. Okay, so we finish 18, and we have 3 examples on calculating the heat evolved and divide by number of moles. It's very important for every question you are asked in the examination. You always have to divide them by the number of moles. Okay, if you have a mass, you have the limiting reagent. Don't calculate the excess reagent because some are not reacted. You get it wrong. So you calculate the limiting reagent first, and then you divide by number of moles of limiting reagent. And in the number 18, you water is the main character here, so that you have to calculate the number of moles of water and divide it by the number of moles of water, and get the result compatible with the equation here. Okay, so we do the basic thing, and then we have two more to do. Number 21. For part 1 I have 2 more, 21 and 22. I want to introduce his law. So his law say that the heat change is only related to the final state and the initial state. It's nothing to do with the route through which the reaction go. It's independent of the route. Okay, they may go by many rules. As long as the final state and the initial state are the same, then the change will be the same. This is his law. Okay, and remember we have some steps. Okay, the first step now, write the equation of the reaction asked to calculate first. So what's most important is the change it is asked in the question. You write the equation here. Now we are asked about 2b become 1c. Then we write this equation here. And the second step, we connect to others, which is given in the question. You are given many heat change. Then you connect it. you try to find 2B, you try to find C, which connect to other reactant or product. So after doing this one, then we look at this 2B here. We do the reverse way. 2B become A. So we write A here. Understand? 2B become A. Then we write delta H1 here. Why we do a minus sign here? Why is here minus sign? Because A to 2B is delta H1. So the reverse way will be minus. And then we want to find C. How can we do C, connect C with A? After writing A here, we find this equation. Okay, so A becomes C is delta H2. So we complete a energy cycle. Then we use his law, going this way, left to right. So we have the same initial state going this way. So it's minus delta H1, and then go this way, delta H2. Then we get the answer B. Okay, to be quick, we look at number 22. It's simple. Consider the enthalpy change cycle. So we have something W become Z, is the heat change will be P, Q, R, S respectively. What are the relationship between them? First of all, we apply his law. Okay, so we look at this one, the root 1 from W to Z. So it is P. Okay, so P will be equal to, we look at the answer choices here, all are P on the left hand side. So we want to have P, W to Z. Then we go the other way, going here, plus Q, plus R, and then this way will be minus S, because S go this way, this will be minus S. Okay, now it's the basic one. So we finish the basic one, part 1, and then I'll make another video in 10 minutes time for part 2. If you have time, if you find you are so good, then you just listen to watch the video for part 2. If you want to have a good foundation, you watch the video for part 1 as well. Okay, I stop here.